Okay.
Yes, yes, sir.
Today we will discuss Euclid's algorithm. What is Euclid's algorithm? This is a process to find out the GCD of two numbers. When two numbers are given to you and you have to find out their GCD, then we need to find a process. Okay, need to find the we have to calculate the GCD, and there is a process. This process is called Euclid's algorithm. Here, this process is as follows: let A and B both are positive. If two numbers are given to you, it may be someone maybe negative or some, but you take both number as positive. Okay, for GCD, no need of negative signs. Okay, we need only divisor. So you uh, you take only positive numbers, and when since both numbers are positive, so uh, one number will be greater than second one. Okay, so you suppose A greater than B. Okay, then by division algorithm, A equal to B Q1, yeah, Q1 B plus R1. Okay, there exist unique integers Q1 and R1 such that this and 0 less than equal to R1 strictly less than B. This is by division algorithm. Okay. Now, next, if R1 equal to 0, then B divides A and GCD of AB equal to B. We are done. Okay. B is our GCD of AB. But when R1, if R1 equal to 0, if R1 0, then A equal to Q1B. Okay. So by definition of divisor of a number, division of a number, B divides A. Okay, because B is a factor, here B is a factor of A, so B divides A. That means then B divides A and GCD of AB equal to B. Now if R1 not equal to 0, then in this case for B and R1, we have two numbers B and R1, and among this and between this B and R1, B greater than R1, it is here. B is strictly greater than R1. So we will again use division algorithm in between these two B and R1. So there exists Q2 and R2 such that B equal to Q2 R1 plus R2, where R2 less than strictly less than R1, 0 or less than equal to R2 strictly less than R1 by division algorithm. Okay, theorem. Now again, if R2 not 0, we will proceed as above and we get R1 equal to Q3 R2. Means we are here using division algorithm between R1 and R2, and R1 strictly greater than R2. So R1 equal to Q3 R2 plus R3, 0 less than equal to R3 strictly less than R2. Okay, the division process continues until some zero remainder appears. इसी तरह का जब तक जीरो ना आए, मान लीजिए R3 not 0, then you can go again. Okay, in this way you can do this until some zero remainder appears, say at the n plus 1th stage, where Rn minus 1 is divided by Rn. The result is the following step of equation. So if you go continue, then you will find this system of equations. A equal to starting one Q1 B plus R1, this 0 less than, ये अब यहाँ लेस देन हटा दीजिए क्योंकि आप 0 नहीं ले रहे हैं. 0 लेंगे तो काम खत्म हो गया. R1 बराबर 0 लेंगे तो then you will get B divides A and your GCD will be B. Okay, so you see here 0 strictly less than R2 strictly less than R1, वो नहीं है. आप 0 यहाँ से 0 की पॉसिबिलिटी नहीं है. Okay, so B equal to this, R1 equal to this, R2 equal to this, R3 equal to this, Rn minus 2 equal to this, and Rn equal to Qn plus 1 Rn plus 0. ये एक एक करके सिस्टमेटिक लिख के आएंगे तो ये सारी चीजें you will find these equations. Now we arrange that Rn, the last non-zero remainder that appears in this manner is the required GCD. That is GCD of AB equal to Rn. ये जो लास्ट है, सबसे लास्ट ये है, देखिए This is okay. Rn minus 1 equal to this जहां यहाँ this non-zero remainder last one. The last non-zero remainder that appears in this manner is the required GCD. So therefore GCD of AB equal to Rn. Now we will prove that how this we will say that Rn is the GCD. We need to prove it. Okay. So our claim is Rn equal to GCD of AB. अब देखिए कैसे प्रूव करते हैं हम. We have Rn minus 1 equal to Qn plus 1 Rn. So this implies Rn divides Rn minus 1. Okay. Again we have Rn minus 2 equal to Qn. Second equation. उससे पहले वाला equation जो Rn minus 1 from this equation. So Rn minus this and you put this value. Okay. Rn minus 1 के value आपके पास है. You put it here. This Rn. So Rn into this. So this implies Rn divides n minus 2. And similarly, continuing in this way, we reach at Rn divides B and Rn divides A. Further, let C divides A and C divides B. Okay? Rn divides each and every number. देखिए A, B, E in this list here. Rn divides all these. Rn minus 1, Rn minus 2, R1, B, A. Rn divides all these numbers. Okay? अब Rn को हम GCD कहना है तो suppose A divides A and A divides B. Sorry, let C divides A and C divides B. Okay. Here you see, here you get Rn divides B and Rn divides A. Okay. अब हम कोई भी नंबर आप ले C. If C divides A and C divides B, then C must divides Rn. Then we will say that Rn is the GCD of AB. यहाँ अभी आप up to here Rn is a common divisor of AB. अब Rn को GCD prove करना है तो you take another number C. Suppose C divides A and C divides B, then C must divides Rn. ये आपको प्रूव करना है. ये यहाँ प्रूफ है. C divides Rn. तो कैसे प्रूव किया देखिए. C divides A and C divides B. Since A equal to BQ1 plus R1, so A minus BQ1 equal to R1. Okay. A minus BQ1 equal to R1. So C divides R1. You see here. C divides A minus BQ1 and A minus BQ1 you see here in your equation this is R1. Okay. C divides R1 and C divides B. C divides B minus R1 Q2. Okay. So this is C divides R2. Similarly C divides R2. ये सारे equation पीछे का देख लेना. वहां से आया इसकी value R2. Okay. C divides R2. So because C divides this left hand side, C divides B है और C divides you see C divides R1 Q2. So therefore their difference C also divides their difference. So therefore C and this quantity जो है it is equal to R2. So therefore C divides R2. Similarly C divides R1, C divides R2. Similarly we can show that C divides R3, C divides Rn minus 1, C divides Rn. Okay. So this implies C divides Rn. You from A and B. Rn divides A and Rn divides B. And here if some C divides A and C divides B, then C must divides Rn. So उस हिसाब से by definition of greatest common divisor, Rn is the GCD of AB. Rn is the GCD of AB. यहाँ डेफिनेशन यूज कर लिया. ठीक है. तो याद रखिएगा जो लास्ट अभी आप एग्जाम्पल में पता चल जाएगा जो Rn कैसे GCD है. ये एग्जाम्पल है. So that GCD of these two number equal to 37 and find integers x and y such that 1147x plus 851y equal to 37. So Euclid's algorithm, we will use Euclid's algorithm. A equal to A, we have two numbers 1147, 851. Okay. So if there is some minus sign, suppose 1147 minus 851, then in the next step you ignore it. Minus sign, you ignore minus sign. Okay. So you will take only positive numbers 1147 and only plus 851, not minus 851. If there is minus 851. Okay. So B, so A greater than B. Okay. So A can be written as 1 into 851 plus 296 remainder. Okay. Now this 851 can be written as of this in the term of this 2 into 296 plus 259. Now again 296 can be written as in terms of this 1 into 259 plus 37. Okay, and 259 equal to 7 into 37 plus 0. ये देखिए यहाँ 0 जहां आया, then this is your, then this number is your, okay, GCD. So Rn equal to R4 equal to 37. So therefore GCD of these two number equal to 37. ओके, जहां कंप्लीटली डिवाइड हो जाएगा, जहां यहां देखिए ये हो गया, अब आपको रिमाइंडर है नहीं आपके पास, सो देयरफॉर दिस Rn इज द Rn इक्वल टू R4 इक्वल टू 37. नाउ आपको लिखना है जीसीडी कैन बी, हम जानते हैं इसी दो नंबर के जीसीडी है, तो जीसीडी कैन बी रिटन एज ए लीनियर कॉम्बिनेशन ऑफ दिस टू नंबर्स, उसके साथ कोई x है और कोई y, ठीक है. अब xy को हम फाइंड करेंगे कैसे, इसी तरह 37 इक्वल टू 1 into 296 minus 1 into 259. 37 equal to, you see here, 37 is this one, equation from equation 3. 37 can be written as 1 into 296 minus 1 into 259. Okay. So 1 into 296 minus 1 into 259. अब ये 1 into 259 को चेंज करिए, 1 into 259 कैन बी रिटन एज 1 into 851 minus 2 into 296. दिस वन फ्रॉम इक्वेशन 2 फ्रॉम इक्वेशन, ऐसे करना, ऊपर की तरफ जाना है आपको एक एक करके. आप स्टार्टिंग यहां से शुरू किया है इक्वेशन नंबर 3 में, जहां आपका 37 है, 37 इक्वल टू दिस माइनस दिस. अब उसके बाद आप एक एक करके बिल्कुल सिस्टमेटिक ऊपर जाइए. ये फ्रॉम सेकंड इक्वेशन बाय इक्वेशन, ये दिस इज इक्वेशन थर्ड, देखिए यू सी हियर, एंड ये जो ब्रैकेट में है दिस इज फ्रॉम इक्वेशन सेकंड. सो देयरफॉर नाउ सिंपलीफाई दिस 1 into 296 माइनस माइनस प्लस और 296, तो टोटल कितना हो गया 196 प्लस माइनस माइनस प्लस, तो 2 और 2 296, तो टोटल हो गया 3 टाइम्स ऑफ 296 माइनस 1 into 851. अब नाउ 296 का वो बदलना है, 296 कैन बी रिटन एज दिस फ्रॉम इक्वेशन 1, 296 3 into 296, so 296 देखिए कितना है 1 into this into 296, ये सी हियर 296 1 into 1147 minus 1 into 851. ओके, नाउ अब इसको सिंप्लीफाई करिए, 3 into this minus 3 times of this and minus this, so minus 3 times और यहाँ एक माइनस, so 3 times of this minus 4 times of this. Okay, so 3 into this plus minus 4 of this, so here 1147x, x की वैल्यू 3 and plus 851y, y की वैल्यू -4. इसी तरह का आप कोई भी दो नंबर हो, आपको बिल्कुल सेम प्रोसेस अप्लाई करना है. ओके, कोई सा भी दो नंबर हो, यू हैव टू अप्लाई दिस मेथड टू फाइंड योर जीसीडी. Okay, now another example, it is solved here. You can see find d when d equal to GCD of this, and hence find x and y such that d equal to 1219x plus 901y. इसको देख लीजिए. ओके, थोड़ा बड़ा नंबर, कभी कभी you can find a greater, मतलब large number. Okay, so you have to calculate, some steps will be there. Okay, now you see some small result. It is, you can say, corollary. If a and b are integers, both non-zero, and d equal to GCD of AB, then the set S equal to ax plus by x y belongs to I consists of multiples of d. Okay, ये कोई इसको सॉल्व करने की आप कोई जरूरत ही नहीं है. ओके, ये सिंपल है, बिकॉज d इक्वल टू GCD ऑफ AB, तो d डिवाइड्स a and d डिवाइड्स b. ओके, so d divides a है तो d divides ax, d divides b है तो d divides by. Already we have proved that if some number divides two numbers, then their sum divides then their sum also. So d divides ax plus by. ओके, इसका मतलब d divides this, इसका मतलब ये नंबर जो है d के मल्टीपल है, या तो d है या d के मल्टीपल है. D is also a multiple of D. Okay, 1 into D. Okay, so दिस सेट इज इस तरह के जो जितने भी मेंबर्स है वो डी के मल्टीपल्स है. इसका मतलब एस कंटेन्स मल्टीपल्स ऑफ डी. इफ एस इज द सेट लाइक दिस देन एस कंटेन्स मल्टीपल्स ऑफ डी. ओके, नाउ सम स्मॉल रिजल्ट्स but interesting. If k greater than 0, then prove that GCD of k kb equal to k times of GCD of ab. Okay, let D equal to GCD of AB and let D1 equal to GCD of KA comma KB. This is D1 and this part is D. Okay, since D equal to GCD of AB, there exists x and y such that D can be written as ax plus by. Now multiplying by k, dk equal to akx plus bky. Now x taking common, ak plus yb equal to x times of k1 plus y times of kb. If that is k of x plus kb of y. Okay, and this is d1 dot r by corollary star. Okay, d1 के मल्टीपल्स होंगे ये d1 इन दोनों के जीसीडी हैं. तो ये जो नंबर से x और y से मल्टीप्लाई करके ऐड जो लीनियर कॉम्बिनेशन है, इट विल बी अ मल्टीपल ऑफ d1, दैट इज d1r. तो dk इक्वल टू d1r. दिस इंप्लाइज d1 divides dk. Number equation 1. Okay, we want to prove that d1 equal to d into k. You see, ये d1 है और ये d है, तो d into k equal to d1. d1 equal to k into d या dk. तो पहला पार्ट we prove that d1 divides dk. Now we will prove that dk divides d1. Okay, now d divides a and d divides b, because d is the GCD of AB. dk divides ak and dk divides bk. So dk is a common divisor of ka and kb, but d1 is the GCD of k and ab. d1 GCD है और dk common divisor है, so therefore common divisor will divides greatest common divisor, so dk divides d1. So therefore from 1 and 2, a and 2, d1 equal to dk. Okay, d1 equal to kd. This implies this equal to this. Okay, this is very interesting result. ओके, ये दोनों नंबर पे कोई के कॉमन है तो उस के को आप बाहर ले सकते हैं. ओके, इफ के इज एनी पॉजिटिव नंबर मल्टीप्लाइंग दिस टू नंबर, ओके, देन यू कैन टेक के इनटू जीसीडी ऑफ दिस. ये नाउ इफ के नॉट 0, देन प्रूव द जीसीडी ऑफ के ए. इफ के नॉट 0, ओके, देन प्रूव दैट जीसीडी ऑफ के के बी इक्वल टू mod k जीसीडी ऑफ ए बी. Let k less than 0, then minus k equal to mod k greater than 0, and by example star we have this. Just it is a corollary of example star. Okay, it is example double star, example star. Now we take negative case. Okay, already positive case में no problem. Mod k equal to k, it is known to us. Okay, so we take only negative case, and if it is the negative case, then by again star we will use this mod k greater than 0. Okay, and using example star. Now prove or disprove these things. If d equal to GCD of AB, then GCD of a by d and b by d equal to 1. This is a small result based on this star result. Since d equal to GCD of AB, d divides a and d divides b. A by b d and b by d both are integers. Okay, now d equal to GCD of AB, GCD of d into a by d and d into b by d. Okay, these two are integers, so no problem. Okay, so d common है. अब हम जानते हैं कि कोई भी common हो, अभी स्टार रिजल्ट में common को बाहर ले सकते हैं. d times of GCD of a by d and b by d. So therefore GCD of a by d and b by d equal to 1. Because dd it is cancelled out 1. Okay, so therefore GCD of a by d and b by d equal to 1. Okay, prove or disprove this result. If b divides a square plus 1, then b divides a to the power 4 plus 1. Number 1. It is we will disprove it. Okay, if a equal to 2, b equal to 5. If we take a equal to 2 and b equal to 5, then a square plus 1 equal to 5 and a to the power 4 plus 1 equal to 17. Okay, so 5 divides 5. b 5 है, a square plus 1. इसका मतलब b divides a square plus 1. b divides 5. But b 5 डज नॉट डिवाइड 17, सो ये डिस्प्रूव है, ये सही नहीं है. ओके, सेकेंड पार्ट, yes, it is true, so we will prove it. How you see, b divides a square minus 1, so a square minus 1 can be written as b into some integer, m belongs to I, for some m belongs to I. Okay, so a square equal to bm plus 1. Now a to the power 4 equal to bm plus 1 whole square equal to b square m square plus 2bm plus 1. And now a to the power 4 minus 1, यहाँ से माइनस 1 इधर ले आइए, a to the power 4 minus 1 equal to b square m square plus 2bm. Now from here in both the term b common, bm square plus 2m. So this is an integer, so b must divide this part. मतलब here b is a factor of this, so b divide this. Okay, so this is all about today's lecture. We have covered a lot of things today. Okay, so in the next class we will continue LCM. Okay, कितने लोग हैं? 1 2 3. आज only 3 students are there. Okay.